everyone, I am Miss Hu, your physics teacher. In this video, we're going to learn about the calculations involving the speed of sound in sound waves. Now let's get started. Let me first get my face out of the way. So the kind of calculations that we are referring to in this video here would involve the speed of sound to calculate distance and depth. Now first of all, in general, how do we determine the speed of sound? Let's say we want to do a lab experiment to determine the speed of sound in air. It's really quite simple. You need to have a meter rule in order to measure the distance where you want to set up the microphones. And then you get two microphones and we place them at a fixed distance apart. So say, for example, we set them at exactly 1 meter apart. Of course, you can place it at any distance that you like, but the further away they are from another, the better. So if you can put it at a distance that's even greater than 1 meter, that would be even better. So this would be the fixed distance that we have already set. Whoops. And then what we do is we place two microphones, one at the start and one at the end, and we connect them to a timer. So the first microphone needs to be set up in such a way that it will start the timer when it picks up sound, and the second microphone is connected in such a way that it will stop the timer when it picks up sound. Now, on the side of the microphone that will start the timer, what we do is we make a sound. For example, we clap. So that will create one very loud clapping sound, just one. And as the sound travels, it will hit the first microphone in order to start the timer, and it continues to travel. And when it hits the second microphone, it will stop the timer. So the timer will then show the time it takes for the sound to travel from the first microphone to the second microphone. In order to determine the speed of sound in air, you need to use the formula for speed of sound. Well, okay, the formula for speed in general, actually. So, can you recall the formula for speed? That's right. The formula for speed is distance over time. So let me just fix this a little bit. Over time. If you look at the results, or the data rather, that we have obtained from this experiment, you can see from here we already have the distance because we have set the distance, which is the distance between the two microphones. So that goes on the top here. And the timer will give us a time because it's the time it took for the sound to travel across this distance that we have set. So that goes at the bottom. And by taking the distance divided by time, you can calculate the speed of sound that has traveled through air. Remember that speed is always expressed as meters per second based on SI units. Now, you might come across a question like this, which may ask you to calculate the distance of lightning from the observer. So let's say, for example, it says here, right? It takes maybe 5 seconds for the sound of thunder to be heard after the lightning is seen. And the question is, how far away is the lightning from the observer? So let's say, for example, the speed of sound in air is approximately 330 meters per second. Okay, how does this work in the first place? Why is there lightning and thunder comparison and all that? So if you can recall what you've learned in science, you should know that lightning and thunder comes together, right? When lightning travels through air, that lightning creates the sound of thunder. So normally when you hear thunder at the same time you see lightning, that means it's happening right in your vicinity. But if there is a delay, that means, okay, the lightning is some distance away. So if let's say this is the observer here, okay. Now, both light and sound need to reach the observer. So we can see lightning because the light has traveled to our eyes, and we can hear thunder because the sound has reached our ears. But because speed of light is very, very high, it's about 3 times 10 to the power of 8 meters per second, about 300,000 kilometers per second. It's so fast that although we can argue that, hey, it does take some time for the light to reach us, it's almost instantaneous. So that means the moment the lightning happens, right, the light has traveled so fast we see it straight away. So it's instantaneous. Sound, however, is not instantaneous. It does travels a lot slower, so it does take some time for the sound to eventually reach us. So how do we calculate the distance of the lightning away from the observer? We use the speed of sound formula. So this is the formula. I'm just going to copy and paste. In this case, we're going to take this. Speed equals distance over time. I'm going to put this as a different color just to make the working a little bit more attractive. So let's put that as green. Okay, and then here's, okay, so speed is distance divided by time, which means that if you want to calculate distance, we just need to rearrange the formula, which will give us distance equals to speed times time. But because we assume that the light to be traveling instantaneously, we can basically the time it takes for the light to reach us is negligible. So we don't have to bother about the speed of lightning, all that. We just focus on the speed of sound. So the distance traveled here in this case, you want to calculate. Okay. To calculate this, we just need to take the speed of sound, which is given to us as 330 meters per second. Hold on, I'm trying to get this to come up. 330 meters per second times 5 seconds. Make sure that the units that you use are the same. So for example, in this case, meters per second and seconds. So 330 times 5 would give us 1,650. And because the unit was meters per second times second, you get meters as your final answer. And this is how you calculate the distance of lightning from the observer given the time it took for the thunder to reach us after seeing lightning. And this is how you can calculate this in real life as well. Let me just realign this. Here we go. This is how you can calculate this in real life as well. So if you find that, oh, okay, I want to find out how far away the lightning is from me, the moment you see lightning, count the number of seconds before you hear it, and then use this formula to approximate how far away the lightning is from you. Now, you also find, you come across questions which involve sound reflection to calculate distance or depth. How it works is this. The device that's normally used to determine distance or depth using sound reflection, there must be a sender and receiver. The sender will send out the sound wave. The receiver needs to pick up the sound wave. So this machine needs to have both the transmitter and the receiver. So what happens is when the transmitter or the sender sends out the sound will travel. When it hits the object, it will reflect off the object as an echo and travel back to the receiver. So it does take time for the sound to travel there and back. How this is used to calculate distance and depth, like in what situation do we use this in real life? Okay. For example, we would use this as an echo sounder to determine the depth of the sea, for example. So how this works is the ship would have that sender and receiver thing. So it will send the sound out, hits the bottom, and receives the sound wave that's reflected back. This is the same technique that's also used to look for, stuff at the bottom of the sea, for example, a shipwreck. They could also use this to look for fish, for example, for hidden treasures at the bottom, or to just observe the corals at the bottom of the sea. They use sound waves. So why they use sound waves is because sound can travel quite fast through water. And in case you're wondering, this is also the same method that is actually used in radar, where we use microwaves to determine the position of planes from a tower, for example. So the same thing, it also uses reflection. However, because this is the sound waves topic, we're just going to focus on sound reflection. But for your information, for radar using microwaves, they also use the same kind of calculation. So how do we use this to calculate depth? Again, we're going to use that formula, which is speed equals distance over time. Let me just reposition this. Again, I'm just going to change color just because. Right, let's use blue this time. All right. Okay. So we already know that speed is distance over time. So what happens is the machine here will then will measure the time it takes for the sound to be sent out and to be received. But here's the thing. The distance traveled is double the depth because the sound has to travel down and back up. So let's say, for example, the distance here, which is from the receiver to here, I'll put this as D. The distance is not D. The distance is double of D because the sound has to travel down and back up. That means distance is actually 2D divided by time, which I'll just put as T. So a short form which you may come across in some books, I know it looks terrible. Sorry, give me just a couple seconds to fix it. Okay, so sometimes they use V as the symbol over here to just make it easier for us to solve questions. So V speed, the distance is, of course, the distance traveled, but in this case, if the depth is D, let me write that more clearly for you. Okay, if the depth is D, then distance is 2D, and the time, T, is the time it took for the sound to travel there and back. So if you want to calculate distance, then you just need to rewrite this formula, and you would get D equals to, bring the T up, you get VT, bring the T down, divided by 2. In fact, just to emphasize this, I'm going to make this a lot larger so that you will remember this formula. And this is the formula you can use when you're calculating depth. Now, remember, you only divide it by 2 when the sound has traveled there and back, traveled down and come back. If it only travels one direction, no need to divide by 2. It's got to go and come back, then you divide it by 2. Now, do you actually need to memorize this formula? No. As long as you can have logic, just use your logic in this case. If you can understand that speed is distance divided by time, keep in mind the distance must be double of D. You can work the formula out from this base formula. So you don't need to memorize this formula. If you're one of those who, oh my God, I can't figure this out, then by all means go ahead and memorize. Otherwise, I highly recommend learn how to figure out the formula from this simple speed, distance, time formula, and you can solve all questions without memorizing too many things. In the meantime, though, let's do the question. Here's an example of a question that involves calculation of depth. So let's say the time it takes between the signal sent and the received signal is 10 seconds. And given that the speed of sound in water is 1,400 meters per second, calculate the depth of the shipwreck detected at the seabed. So if you want to use a speed distance formula, I'm just going to copy this because here we go. Okay, here's the speed distance formula. So you can use this to figure this out. And of course, you can just straight away use this formula if you like. Hold on. Okay. And then you work this out. So again, just to show you how we work this out, you've got this formula and you've got this. So to solve it, now that you know, okay, D equals VT over 2, let me write this out. Okay, so from here, D, which is the depth, V is the speed, 1,400, and time is 10. Just divide this by 2, and you will get 7,000 meters. And that's how you solve this question. You might come across some questions that are a little bit more challenging. For example, we have a situation like this. So there's no question here. Let me just get the question real quick. Now, sometimes you may come across questions that are a little bit more complicated. For example, this kind of question. So in this diagram, you have a cliff and 2 men, 1 man with a gun and a second man who's just listening. Now, the man with the gun is not shooting at the second man, okay? He's just shooting in the air. So, in this question, okay, when the man with the gun fires the gun, the second man hears 2 gunshots. And the question is, what is the time interval between the 2 gunshots that the second man hears? Now, if you're wondering, 2 gunshots? Why would he hear 2 gunshots? There's a cliff here for a reason. So the first gunshot that the second man hears is the first sound where once the gun fires the gun, the sound travels this way. So the second man hears the first gunshot. But remember that sound doesn't travel only in one direction. It travels in all directions, which means that the sound can also travel this way. But when it hits the cliff, what happens is that it will reflect, basically an echo, and then it travels away. So the second man actually hears the second gunshot, which is the echo from the first gunshot. So that's why he hears two gunshots. So again, the first gunshot is when the sound from the gun reaches him directly first. The second gunshot is because of the echo of the cliff, and then the sound reaches him. So to calculate the time interval, you need to first of all calculate the time it takes for the first gunshot and then the second gunshot, and then get the difference in time. So how to calculate? So in this case, you can't use d equals vt over 2 directly like this, because this one is when the distance traveled is the same, right? When d is the same in both directions. But here, although there's an echo, it's not the same. So I suggest you use the speed equals distance formula, speed equals distance over time formula directly, and use your logic to figure out the distance. So just for clarity, I'm going to use blue and green. So blue would be for the first gunshot, while green would be for the echo of that gunshot. So for the first time that we hear, right? So using speed equals distance over time formula. So just to remind you about the formula, so I'm going to copying and pasting, because hopefully that's faster, right? Speed equals distance over time. Just going to put it as a different color just to make it clearer. Okay. So speed equals distance over time. So for the first one, we know that speed is about 300 meters per second. The distance traveled here is only 300 meters direct to him, right? 300 divided by, I'm going to label this as T1. So this means T1, change it over, 300 divided by 300, this would be 1 second. Now for the second time, the second gunshot that we hear, you can see that, okay, the distance traveled, let's write the speed first. So that's 300 equals to, now to get the total distance, you have 150 here, 150 here, and 300. So I'm going to write that over here. 150 plus 150 plus 300 divided by T2. So if you can already solve it, by all means go ahead, but I'm going to do this step by step for those of you who need to see this, so you can see 150 plus 150 plus 300 gives you 600. And T2, change the place, you get 600 divided by 300, which gives you 2 seconds. So the time interval is the difference between these two times. So the time interval here, bigger minus the smaller, which means 2 seconds divided, 2 seconds minus 1 second equals to 1 second. And that's your answer. And that's how you calculate the time interval between the two gunshots that the second man hears. So again, remember, just use the speed, distance, time formula and use your logic to figure out the distance. And there you go. So I hope you found this video educational and helpful. Don't forget to click like and subscribe for more lessons, solutions, and exam strategies from your physics teacher, Miss Ho. Happy studying!